right, let's start with the ordered means handout, the one that's got the one that's got the screening stuff on the front here. This is just basic stuff. It's stuff that you've already done previously, so I'm just going to work through output here and kind of walk you through things you should be thinking about in terms of breaking down some of the screening stuff. So with this, remember, we're looking at whether or not we see differences in repeated assessments or repeated response to different vignettes across these different belief classes. And if you pull up your data set, your beliefs rating data set that we've been working with previously, remember now we're going to introduce class as a variable, and we're missing some cases there, so we're going to go through, and there's 8 cases that don't have class, so we're going to have to go through and get rid of those. So we'll go through, clear that, and then resave this as scrap or something like that, whatever you want to name it as. So we're not screwing around with our primary data set. And then, once we've identified our missing variables, we'll run through some of the screening stuff that we would typically do. So here, just looking at the frequency of our different classes, right? So we've got 44 in the negative, 94 in the benevolent, and 85 in the interpersonal. Is this relevant to these analyses? Probably, right? We've got a clearly unbalanced design. It's not way off base. We wouldn't call any of these classes, categorical outliers, but it's still, we've got, over twice as many people in the benevolent as the negative class, right? So this is one of these things that we're going to start to have to keep in mind and think about in terms of assumptions. Remember, as soon as we start to have unbalanced groups, the extent to which our analyses are robust to certain types of violations starts to go down, right? So we want to keep an eye on that. We go through, we take a look at descriptives, just means and standard deviations for each one of our vignette ratings. Again, here just wanting to take a look and make sure that we haven't missed any, that there are no missing values, right? It looks like we have full data for all 223 people. It looks like our values are all within plausible range, so we're doing pretty good on there, right? But now what we need to do, go back into first semester stuff, remember that this is a group-based analysis, right? And so when we're going through and looking at our screening, we need to go through and look at distributions within individual groups, right? Because you might have a value in one group that's just fine, but that value could be a horrible outlier in another group, depending if you've got really different things going on across your conditions, across your groups, things along those lines. So on your sheet, what you see, we've split our file by class, and then have gone down through and run our descriptives and asked SPSS to save our standardized values. Remember, always when you're doing these group level analyses, always want to split your file before you calculate z-scores. What's going to happen if we don't? Katie? Yeah. We're going to standardize it based on the group mean, or what we call the grand mean, and the standard deviation for the whole set, and that's going to screw us all up, right? So we want to go through and make sure that we split the file by our categorical or by our grouping variable, and then go through and take a look. That's what we've done here. And I don't know, can anybody see, what do we have going on this screen here? Basically, it's not good things, right? We've got, for our negative group, we've got a high skew of negative 2.6, max kurtosis of 8-ish. Our benevolent group, we've got a kurtosis value, high kurtosis of 17, and a skew of close to negative 4. For our interpersonal class, we've got one of our ratings, we've got a negative skew over 3, kurtosis value of 11, okay? So we're getting really, really ugly observed distributions in these analyses. Are we concerned about this? Shaking your head, no, why not, Stephanie?
Because this is based on the distribution of sampling.
Right. So we're worried about distribution of the sample means, right? But this is still some pretty ugly scores, at least based on our indices, right? What's the one thing that, and if we think about distribution of sample means, right? And if we think about what we've asked people to do, these are ratings. So if people go through and read a vignette about someone who's had something terrible happen to them, and then we're asking them 0 to 8, how willing are you to provide friendship to this person, right? Is this something that's going to have a normal distribution of the population? No, it's probably going to be pretty negatively skewed. What's the other condition where we would expect a normality in the distribution of sample means? Large sample sizes, right? And so we've got unbalanced samples here, but our smallest cell has 44 people, our largest has 94, I think. So we've got some degrees of freedom there, right? So our sample is probably going to be fairly robust, even though we've got some pretty ugly screening or pretty ugly observed scores in terms of our distributions. We've still got pretty large, we've got large cells. And so we're probably okay, but it's certainly something that we can't just write off or say, okay, this isn't an issue. Right? So we go down through and request graphs for these. We can start to see that that's looking. So this is going to be for our ratings for willing to provide friendship to people in motor vehicle accidents. Right? This is our negative group. This is our benevolent group. This is our interpersonal group, right? Those are all not great. Your box plot is looking terrible, right? Same thing with combat survivors. Our negative, we got someone who's down here reported to 0, right? Clear negative skew, stuff going on here, right? So that's not great. Again, negative skew. I guess they're all skewed in the same direction, which is helpful. We've got gross stuff going on here too, right? So at this stage of the game, our question is, do we need to transform? Well, I don't know. It might be worth looking into, right? I mean, with our group-based analyses, our assumption is normality and distribution of sample means, not the observed means. So we could be okay, but with something as extreme as this, I might think about it in terms, I mean, so this is a 0 to 8 scale, which kind of has some intuitive meaning to it. And if we transform, we lose that. But we also don't want to get funky results just because we've got weird data, right? And so this is a case where I might go through and do it both ways. I did on this. Turns out transforming doesn't have any minor differences across 50 different tests, right? But this is something where you might want to consider, does it make sense to go through and transform and see what's going on, okay? So we've got unequal cells, we've got ugly observed distributions. Now, if we go through and we take a look at our z-scores, right? We're looking for potential outliers, and of course, we've got, for a negative group, we've got a max z-score of -4 over negative, or under -4 for someone, and a z-score of close to 5 for benevolent, over close to 6, right? Interpersonal. So we've got very clear scores that are falling several standard deviations below the mean of each one of our samples. Are we concerned about this? What do you think, Angela? What's that?
Well, this, an assumption is looking at variant outliers or something, or I don't know.
Yeah.
I think yes, we're interested in it, but I don't know if we're that concerned.
Okay. Why might we not be running around the room with our hair on fire when we see this stuff? These Because what I usually see is an outlier that's 5 standard deviations below the mean. But we'll probably be concerned about that.
Because everyone's saying your standard deviations are fairly small and everyone's like 80 together. So
Yeah, well, that's one thing, right? If I go through and I take a look, there's, people are, almost everybody is maxing out, right? As you would expect, right? We get some variability in the tail, but, I mean, if we go through and we take a look at our box and whisker plot, you know, I mean, we see for these two groups, the median, the third and the first quartile are all the same value, right? And so there's, not that there's not variability in here, but everybody's really kind of stacked up at one spot. Okay, so we might sort of take that into consideration. What else might we take into consideration?
So large sample, this you severe enough that holding that outlier won't hold you too much.
Okay, almost perfect, yeah. So we've got fairly large cell sizes, right? And we've got clear skew, but there's only so far out a variable a value can be. Again, this isn't a continuous score, right? It's ordered categorical at best, right? And so if everybody's reporting an 8 and one person reports a 0, that's going to be a huge outlier, but it's probably not going to drag it off. Again, when we get into different types of social sciences and things, when we're looking at variables with no conceivable upper limit, like income and things like that, then we can have people start dragging our stuff around. And if we had really small samples, this might also be a concern, but we've got decently large cells. I mean, one cell, we got close to 100 people, right? On a 0 to 8 scale, one person isn't gonna completely screw you over, right? And then the other thing that happens with the distribution like this, let's say, and we say, oh, well, this person, we got one person who's a 4, they're an outlier, right? And I'm gonna get rid of that person then, I'm gonna pitch them out. What's gonna happen now when I rerun this and analyze for outliers? Am I gonna be good? No, now these are just all gonna be outliers, right? And so basically we're starting to remove all the variability that's gonna be interesting, right? We're throwing out people who aren't specific. So for this class, right, I wanna go through and make sure that this is actually a real score, right? But at the end of the day, that person's actually someone I'm interested in, right? I want to be careful that I'm not just throwing out the data and the data points that are actually of interest, right? So in terms of the outliers, if I was going to do something with those, I probably wouldn't cut or smooth anything, because there's no way you can smooth that distribution and make it look okay, right? If we smooth things in, things are still going to be 3-4 standard deviations below the mean, right? So with this type of thing, I might consider looking at transforms, but then again, so it's kind of one of these things. I think you can go a couple of different ways and just want to justify, right? For these data, I would say, well, I kind of want to retain this idea of the 0 to 8 scale. It doesn't have any intrinsic meaning necessarily, but it kind of tells me sort of relative to where people are at, versus if I log transform something, then that's kind of weird. And so maybe I would run it if I was really concerned, and I might be with this. I might run it with a transform and run it without and see if I'm getting wildly different things. And then I need to sit back and say, okay, well, what's going on, right, before I move forward. But these are some things I want to take into consideration. Okay. Questions on any of this? Yes, Sam.
So we apply like the independent cycles as assumptions to these kind of groups screens, right?
Yeah. Or your ANOVA stuff. So you've got a couple different, and if you look on that last slide in the PowerPoint, you've got different assumptions, right? So we've got assumptions that involve our within subjects effects and assumptions that involve our between subjects effects, right? Now this is a means-based analysis at the end of the day, and so we have some concern about distribution of sample means. We're probably okay here. We've got clear severe cases that are registering as outliers, which we'll want to think about, right? But all of this is just based on, is this going to be a problem, or is it something that these analyses can handle? It's certainly not great. I would love it if the data didn't look this way, but they do. So just one thing about what's the potential impact of this on my analyses, my inference, so on and so forth. Okay. So the other thing we want to do here, as we're going through and taking a look, what have we not done that we want to do here? So we've got a sense that one, unbalanced design. Two, we've got violations of normality and are observed. Univariate outliers. We're not doing so great with this screening thus far. What's the other thing that we want to take a look at? What's that? Is altogether, yes, homogeneity of variance stuff, right? And remember, with these designs, we've got homogeneity of variance concerns both within and between, right? And so if we go through and we take a look, and remember that we want to be looking at variance and not standard deviations. But what I like to do with this is I like to put together a matrix of my cells. Okay. Now here we only have one between subjects factor, but if we had a second between subjects factor, what would we do to avoid moving into three-dimensional space? Make these your cells, right? Individual cells. So that right now these are groups, but if we had, say, gender in there, right, then this would be negative male, negative female, benevolent male, benevolent female, interpersonal male, interpersonal female, right? And going down through and taking a look at this, right? And so we go through and we calculate the variances across here. I just did this, we'll do it quick, so. What do we see if we're thinking about this, right? So we have a couple of different assumptions. We want to see homogeneity of variability across our repeated measures, right? And homogeneity of variance across groups, right? And if we go down through and we go down through and we calculate our F max, 2.5, 6, what are we seeing based on that? Do we have any concerns? We're not excited about it, right? Remember, with an unbalanced set, F maxes, an F max as large as 3 can be kind of problematic or concerning, and we see in between groups, right? So this is our motor vehicle accident, 2 is our combat ratings, right? And here we've got a variance of about 3 for our negative group and less than 1 for our interpersonal group, right? And so we've got what appears to be potential problems with homogeneity of variance across groups, right? And we'll test this more formally with Olivier's test when we go through and request our analyses, but our Fmax should give us a sense that we might have some concerns here, right? Now, if we're looking within group and across measurements, I mean, this might be problematic, right? It looks like we maybe have more variability here, same thing here. This is actually looking closer, right? And so might want to go through and take a look in your screening, say, just based on your Fmax, you're suspecting possible violations of homogeneity of variance across groups for individual assessments. Homogeneity of variance of assessments within groups is looking better, right? But it still looks like we've got one group that's doing something maybe a little bit different than some of our other groups, right? But if we ignore column 2 here, these are all pretty much the same. Those are very similar. That's a little bit lower, but these aren't too bad. It looks like there's something different going on with this one group, okay? And this is important. So the one you're going through, you're taking a look and saying, okay, am I meeting all my violations, things like that. But again, starting to get some insight into your data. Is it what's going on with 2? What is it about 2 that looks like it's systematically different than some of these other ratings, right? This type of stuff can be tedious, but it's giving you ideas about what types of stuff might be going on with your data, which can be important. Okay. Yeah.
Sorry, I missed the part about what are the circle numbers?
Those are your Fmaxes. This is a ratio of the largest to the smallest variance. So this is 299 over 1.08. 1.11 over 0.56. Okay. Here is 1.05 over 0.43. Right. So these are just your Fmax ratios. And this is just tricky because you have to be looking at both between and within with these designs, and so this is just something that I'll just lay out and do that makes sense to me. Yeah.
Another question: when we do this mid thing, we're not concerned about like the sample size, right?
Well, we kind of are, right? Because it looks like, again, this negative group has the least amount of people. It's got the greatest amount of variability, right? And so probably what's going to happen is this group is probably going to have an undue influence on our error terms, right? And this is when we're thinking about how do we go about running contrasts and how do we go about calculating effect sizes, right? Our concern with just hijacking error terms out of our ANOVA table is that error term representative of whoever I'm trying to look at, right? And it looks like there's way more variability in this group than these other groups, and so this is going to start to go in and play into my considerations on how I'm going to go through, how I'm going to approach follow-up tests, what's going to be responsible effect sizes to calculate, so on and so forth. Okay. Other questions? All right. So then we would say for violations of homogeneity, probably, right? What's the other thing that happens with these designs? An assumption that we need to be aware of. Thoughts? Our spurious assumption, right? Now we always assume that we violate that, right? And so in your screening, you say, yep, we probably violated that before moving on. But this is just gonna be initial run going through and taking a look at some stuff. So what we're gonna do, we can go analyze, general linear model, repeated measures, name our factor, we're gonna name it here, class, and then TR rating. What are we talking about there? Comma rating. All right, we're going to use 4 levels here, right? So we're going to define. We're going to have our accident, combat, sexual assault, and disaster. Populate our repeated measures. Class is going to be our between subject factor. And then we're going to go take a look. This is model stuff, we don't worry about that. Contrasts, not worried about this. Plots, what we want to do is we want to have, let's have separate lines for class and our repeated measure on our horizontal axis. We'll add that plot so that'll just, I don't like SPSS's plots, they suck, but this is just an efficient way to go through and kind of eyeball, get a sense for what's going on. Post hocs, we want to go through, we can take a look at, actually don't do this, not going to be useful. What this will do is it'll give you post hoc tests for across your classes, but we've got a whole within subjects thing that needs to be going on, so don't worry about that. I'm going to save anything within options, okay? So we can request marginal means for class rating and class times rating interactions. These will give us kind of just a sense of our marginal means, kind of what's going on. We'll ask for descriptive statistics, estimates of effect size, and our homogeneity of variance test. This time it won't yell at us, it'll actually give us a homogeneity of variance test because we've got a between subjects factor in there. We'll need to continue, and then hit OK. So now we've back to what we've got on your handout here. And we've gone through and taken a look at this before. Remember, these are just yourselves, this TR rating, make sure that your repeated assessments are in this order that you think they're in, right? We have our between subjects factors telling us how many people we have in each cell. Again, we already knew this because we looked at this in the screen, but this is just making sure that we're good to go. This is our descriptive statistics broken down by individual cell and then our total, right? This total value, these are the means that are being compared in your between subjects factors, right? That between subjects test, that's looking at, is the mean rating for friendship or for, well, this is what's excuse me, this total, this is what's being evaluated in your main effect of assessment or your repeated measure, right? Collapsing across groups, does this mean differ from that mean, differ from that mean, differ from that mean, right? So collapsing across groups is the mean rating for friendship or for MBA different than combat, different than assault, different than disaster, right? If we were to go through and look at our between group stuff, it would say collapsing across rating. Do we see differences for benevolent, negative, and interpersonal groups? And then these individual means here, these are going to be our cell means, right? Boxes test, we can ignore that. Multivariate tests, we're ignoring that. Sphericity test, we can ignore this because we're assuming that we violated sphericity. And then we move down to our between subject or within subjects test here. Remember that here we see that we have a main effect of our assessment rating, indicating what? Sam, what is this main effect of assessment tell us?
That somewhere there is differences
over time, right? There's some ways, so our repeated assessments are different some way, right? So somewhere across our repeated assessments, collapsing across group, right? The mean rating of our individual assessments is different somewhere in there, right? Always, always, always make sure that you, in your head, every time you do one of these, go down through and make some interpretation of each one of these effects, just as practice to make sure that you've got a good head for what's going on. So we look at our greenhouse geyser corrections because we are assuming that we've violated sphericity, and we're seeing that we have a main effect of assessment. And so we're saying that collapsing across groups, there is some, it appears that there's, that these data would suggest that there's, these mean ratings are different across different vignettes somewhere, right? At least two of these are different from one another. It's tough to tell, we can't tell from the omnibus, right? But then we go down through, we also see we have a between by within interaction, right? We've got an interaction of belief class across assessment rating, suggesting that the pattern of means across each one of our repeated assessments differs in some way across our classes. Okay? So basically, this is our moderation test. And we know that because it's interaction. Anytime we get an interaction, it's moderating effect, right? We're saying that class membership moderates the pattern of means across our repeated assessments. So there's something going in there, right? A good way to think about this, remember if we're plotting this out, what does a not interaction look like? If we're plotting things out in a line plot. What's that? Parallel, right? And so I might get something that looks like this and looks like this. These groups aren't the same, but the pattern of means is the same, right? It's just kind of a difference in elevation. This group appears to be higher than this group overall, right? So I might get a main effective group in these analyses. I may get a main effect of assessment, right? Given that these are jumping all over the place, but I'm not going to get an interaction because these two things are parallel to one another, right? Always remember that if you're going through and taking a look graphically, and if it's a bar plot, so would we see, or we would connect the tops of these, would we see some sort of crossing or eventual merging of stuff? So this interaction is telling us that we don't have, probably wouldn't expect to see parallel lines here. And so our pattern of ratings across vignettes is impacted by our group membership here. Okay. Our within subjects contrasts, are we interpreting this? What do you think, Laura? No, why not? You're on the right track, right? Does the order of means make sense in this example? No, right? Like, oh, but look at this. I have a interaction. My interaction effect has a cubic trend. I don't know, right? Like you shake this up and like throw it out in a different order and see what happens, right? Again, don't get sidetracked by p-values. None of this is meaningful. This has no interpretive value. This is one of the things people complain about at SPSS. It doesn't give you stuff, even though it isn't interpretable. You can't make any interpretations off of this. Okay. So we go down through and we see Levine's test is significant. Angela, tell me what these Levine tests are telling me. Do we have violations of homogeneity of variance? Where? Take a look at the table. What does it look like those are testing? So these are going to be between, right? So this is going to be our test. So across our three groups, it looks like for interpersonal, negative, and benevolent, our friendship, the variability and our variance of our friendship ratings are different across these groups. Same thing with combat, suggesting that the variance our estimated variance is different across our three groups. Same thing here, right? So our Levine's test is always going to be a test between groups, homogeneity between groups variance. Okay? And so we can see for each one of these ratings, for each one of these repeated measures, we violated homogeneity variance across our groups. And we shouldn't be surprised, right? We're getting the sense that this might happen based on our FMAX stuff. This is just additional evidence that, yeah, we should probably not assume that our variances for each one of these ratings are equal across groups. Yeah?
So, it's saying that MBA group is different from the other groups, including the repeated record part?
No, other way around. So for our vignette rating, for our rating of vignettes for our car accident, it looks like the variability of responses in our interpersonal group and our negative group and our benevolent group are different, right? So these are just, think about each one of these as a as a test of your between subjects factors, right? So remember, if you were to run like a one-way ANOVA for friendship, for car accidents, and then another one-way ANOVA for combat, and then another one-way ANOVA for assault, another one-way ANOVA for disaster, and you were to run a Levine's test on each one of those, this is what you would get, right? This is just, remember when we said with these mixed designs, what we're doing is we're sectioning things off. Think about it, it's first running like a between subjects ANOVA, and then taking that, setting that aside, and then using what's left over for our repeated measure stuff. This is just saying that across our groups, we have violations of homogeneity of variance in ratings for MBA, in ratings for combat, in ratings for assault, and in ratings for disaster here. Okay. So we don't get a formal test of our within, so whether or not for our negative group, whether or not we have equality of variance across our repeated assessments, that's not tested in here. This is just when we get the between subjects factor. And so this is why when we went through the requested homogeneity of variance test in our one-way repeated measures ANOVA, it wouldn't give us anything because there wasn't anything to test. It wasn't a between subjects factor. People feeling okay about this? Okay. Here's our between subjects test. Again, we typically would not put too much stock in this. In this case, it's kind of interesting. Again, what this is saying is if we just collapse across repeated assessments, right? If we take within each group the average rating for all of the vignettes and collapse them across, it looks like we're seeing differences in average vignette rating across negative, interpersonal, and benevolent groups, right? We would have to go through and do a follow-up to see exactly where this was going on, right? Probably what I would do is I would manually calculate average group level scores collapsing across repeated assessments and then go through and take a look. But essentially this is saying that somewhere, right, if we just take the average rating, average vignette rating for each one of our groups, we're seeing some between group differences here, which is actually relevant in this case because it suggests that on average, at least one of these groups is rating things a little bit differently than other groups. We don't often look at this in our in our mixed designs. Again, remember our between subjects factor in our mixed designs is often used to sort of suck out variability, but in this case it ends up being kind of relevant. So you just want to know kind of what different things mean as you're working through stuff. Okay? And then here's your marginal means, right? So we can go through, and I guess here this is a good example. So this is your marginal mean for class. So again, this between subjects effect. So on average, the marginal mean for vignette rating for our negative group is 7.2. For benevolent and interpersonal, it's 7.6. Right? These means are what's being captured in this between subjects effect. Okay. Meaning that on average, people in the negative group are rating these vignettes, are reporting lower levels of willingness to provide friendship than are the other two groups. Again, this is a very, very subtle difference, right? But again, that's part of the power of these designs. This is our marginal means for our rating. So this is on average collapsing across groups. This is the average friendship rating for motor vehicle accident, for combat, for assault, and for disaster. And then when we drop down into the interactions, this is stuff for our individual cells. And then we drop down into our actual plot here. So we can say, okay, so what it looks like is going on is that just eyeballing things, it looks like we've got a clear deviation here. Overall, the plots are fairly similar in shape, but they're not parallel, right, Morgan? This one's way down and then way back up, right? So not, as you pointed out there, they're kind of the same form, but they're not the same thing going on here, right? And this is, we see an overall decrease in the elevation of our negative, which is, again, we saw, probably had guessed in our marginal means and our between subjects effects. So overall, we would say collapsing across these, and we took the average of these points for our benevolent, average of these points for our interpersonal, average of these points for our negative. We're seeing where that's coming up, right? But then we're also seeing that it looks like even within groups that we're seeing differences here. And so this is what is going on in that between by within interaction. This is our class by repeated assessment interaction going on here. So that was a lot of recap. I just want to make sure we're all on the same page before we start talking about how to jump in and probe this stuff. Anybody have any questions about sort of what we've done up to this point? Okay, so this is where things get tricky. How do we go through and start probing this? How do we start probing this interaction effect? There's a lot of different ways that you could do this. Okay, we've got how many cell means do we have here? What's that? 12, right? Now, if we wanted to, the number of pairwise tests, so we would take 12 times 12 minus 1 over 2 is going to give us, what's 12 times 11 divided by 2? $66? Okay. So there's 66 possible pairwise comparisons in that plot. Are all of those meaningful comparisons? No. Why not, Marie?
Don't know, because I haven't gotten that far in the video.
Thinking back to our between subjects ANOVA, if I've got, say, a 2x3 just between subjects ANOVA, does it make sense to compare males in condition 2 to females in condition 3? You know, we're crossing stuff, right? So there are 66 possible pairwise comparisons in that plot, but not all of them are interpretable. So if you were to go through and just ask SPSS to give you post hoc tests, how many tests is it going to control for? 66, right? Do not do this, okay? What we want to do, though, is see how many means are there that could, if we wanted to do pairwise comparisons, how many reasonable pairwise comparisons are there? Well, if we think about our within groups, right? So we've got 1, 2, 3, 4. We've got 4, within each group we've got 4 repeated assessments. And within a group we could compare any 2 of those repeated assessments. I don't know that we want to, but we could, and that would be meaningful, right? So we've got 4 means, 4 times n minus 1, so 4 times 3 divided by 2 is 6, right? So we've got 6 possible comparisons here, 6 possible comparisons here, 6 possible comparisons here. So we've got 18 within, and then if we wanted to do between subjects at each one of these time points, right? We've got 3 groups at each time point, right? So we've got 1, 2, 3. So we've got 3 comparisons here. 3, 6, 9, 12. 12 between. For a grand total of 30. So at each, for each vignette, we've got 3 groups rating each vignette. For each group, we've got 1 versus 2, 1 versus 3, 2 versus 3. So there's 3 possible pairwise comparisons. Take those 3 and times that by 4 assessments, and then we get to 12. So I would encourage you, anytime you're faced with one of these, to go through and actually take a look and say, what are the possible pairwise comparisons that could be made based on sort of this, right? This is going to help start to create some clarification. Now, is anybody interested in running 30 pairwise comparisons and interpreting those? No, that's a lot, right? The random stuff is going to come up. Our job is to go through and come up with some system to qualify this interaction. What makes sense based on literature, based on research questions? How do we go through and tease this apart? This is tricky, right? And this is also another thing too, when thinking about your designs, keep them manageable as possible, right? If you've got 4 different factors with 5 levels on each, it's going to get nasty real fast, right? And it's going to be hard to sort of get a sense for what's actually going on here, okay? Now, we're going to play pretend for this, and we're going to say that this is a secondary study that we've run, right? We've already done something similar to this, and we already think that a priori, we're expecting that people will report less willingness to provide friendship to survivors of military trauma, let's say, versus civilian trauma, okay? And so in this hypothetical example, let's say we're coming in and we're saying for our within, we're expecting combat to be less than all other, okay? Now this is convenient because it kind of looks like that's what's going on. But we're going to pretend that we came in to this design already expecting that in general people will be less willing to provide friendship support to survivors of military trauma versus motor vehicle accidents, disasters, assault types of things, okay? So what does this imply for us in terms of teasing things apart, Katie? What might I do if this is my hypothesis? Combat against all others for who? Based on my interaction. For negative, and who else? And for all 3 of my groups, right? So what I'm going to do is I'm going to run a within subjects contrast comparing combat against all other types combined, right, for each one of my groups, right? So I've got a total of 3 tests here, right? And I'm making this test a priori, right? So I'm not going to worry about controlling for this because I've got these 3 tests that I said on the front end that I'm expecting, regardless of what happens, I'm expecting across groups that people will be less willing to provide friendship to survivors of combat trauma as opposed to other types of civilian trauma, okay? And so what I'm going to do is I'm going to test these per comparison rates. Because I made this in this hypothetical example, I called this shot before going in. This is important. Have some hypotheses before you work into this stuff, because otherwise, and this is actually quite nice in terms of, I mean, it's pretty easy to kind of see what's going on, but this isn't always going to be the case. Particularly if you've got small samples, things are going to be all over the place, right? You want to have some game plan moving in so that it's not just a free-for-all and you're trying to pick things apart, okay? So for my within, I'm going to run 3 contrasts. And I'm going to say, all right, I'm going to compare combat with all others, but then I've got these between subjects tests too that I might be interested in, right? But let's say that I didn't come in with any strong idea about across each one of these assessments what my different groups might look like, okay? Now when I look at this, I say, oh, well, it looks like my interpersonal, my benevolent group are looking pretty good, right? and my negative group is looking lower. So maybe what I'm going to do is I'm going to, for my between, I'm going to compare neg less than all other across each one of my individual assessments. Okay. Which is fine, but what's the problem with this? And how many of these contrasts can I run, Sam? How many ratings did we have? How many repeated assessments did we have? 4, right? So I can run 4 of these, okay? So I've got 4 tests. Well, what's the problem? I didn't say, okay, I'm going to correct for these 4 tests that I'm going to run. Why might I not be satisfied with that if I'm being strict? How many tests did I really run? I looked at that and I kind of just ran them all in my head, right? And I went through and I cherry picked the ones that were most different. And then I tried to consolidate, make my life easier and say, well, I'll just group these ones together against the other ones, right? Essentially what I did is I ran 12 tests, right? Because I looked at for my first vignette, I looked at all the differences between my 3 groups, and then I did the same thing at vignette 2, vignette 3, and vignette 4. So what I've actually done is I've ran 12 tests and just decided to only run these 4 specific contrasts, but I'm cheating if I just said, oh, what I did, I just cherry picked the ones with the biggest means, with the greatest likelihood of turning up as positive, right? And so what I'm going to say is I've got 12 tests to correct for. Okay. Now I need to figure out how I'm going to go about doing this. This is going to be tricky, right? There's no right answer for doing this. This is going to be based on what you're comfortable with, how you want to approach things, what your question is, a lot of different stuff, right? So we could Bonferroni correct for 12 tests. Do we want to do that? No. Bonferroni is not a post hoc test, right? That's going to be too much. We could use Benjamini-Hochberg, but that's problematic with because we're not looking at pairwise tests. I mean, we could, because basically we could go through and we could take a look and say, run, but that would require us to go through in order to do that. We'd have to run all possible pairwise. We'd have to run 12 pairwise comparisons, and that actually doesn't get at our actual contrast that we want to run, and so that's kind of tricky. Okay, so what I might do here is I might say I'm going to try and rig up some sort of modified Tukey here. Okay, so remember with Tukey, what we want to do is if we were going to go through and we run, say, Tukey at this time point, right? What we could do is we could say, well, I've got 3 means, so R equals 3, right? And so if I set R equal to 3, how many pairwise comparisons is Tukey going to count for? 3, right? 3 times 2 is 6, divided by 2 is 3, right? So R tells you how many means that you're working with, and then how many corrections how many tests you're going to get corrected for. But we can't really do that, because if we just plug in the means here, it's going to correct for stuff that doesn't make sense to correct for. So what I might do is I might say, well, let's see if we can find something that gets close. Okay? So let's say if I set R equal to 5, how many tests am I going to be correcting for here? 10, right? What if I said R equal to 6? 15, right? So I'm kind of, if I want to correct for the B, if I'm trying to be responsible and say I just eyeballed that and then just made up the ones that I want to look, but I actually ran, let's say, 12 tests, I kind of fall in between here, right? And so depending on what we want to do, if we want to say good enough or want to be more conservative, in this case, let's say we want to be more conservative, and so I'm going to test, and I'm going to set R, I'm going to correct for 15 tests here, right? I'm assigning myself more of a penalty just because this is straight up exploratory stuff. I've got a really big sample, right? And so I'm going to go through and say, for my strategy, I'm going to set R equal to 6 in this modified 2 key because I'm going to correct for 15. It's going to be too much, but I'm just going to call it conservative, okay? And so what we can do, we go to the interwebs, and I say, critical value calculator or something like that. Pull up all sorts of wonderful tools. I like this Vaster stat one, so I can go through and punch that, and I can say, okay, I want to find my critical value for my student range statistic, my 2PQ, okay? And then K, the number of K is equal to R here. I want to control for 6, which is going to give me a correction for 15 comparisons. But then I need a degrees of freedom, right? Now, what's my issue with my degrees of freedom in this here? They're different, right? And so depending on which pairwise test I'm doing, it's going to change my degrees of freedom, right? And so there's a couple of different things we could do, right? We could say, well, because I'm in my contrast that I'm planning, I'm actually going to go through and take a look at all of my people, right? So I could say, well, I'm going to set my contrast, or I'm going to set my degrees of freedom to, because they're going to use everybody in the sample, I'm going to set it to 221, right? Because each one of my contrasts is going to be, I'm including all of my people in there, right? So I could say I'm going to set my contrast to, or my degrees of freedom to 221, because that would be the degrees of freedom for the contrast that we're actually going to be taking a look at, right? I could also say, well, I want to be conservative, and I want to go through and I want to take a look at and use the degrees of freedom for the smallest contrast that I could make in there in terms of pairwise stuff, right? And in this case, that's going to be degrees of freedom 127, right? Because if I do an independent sample t-test for, say, my negative group versus my interpersonal group, so that's the two groups that have the lowest number of people in there, right? That would be 44 plus 85 minus 2, which is going to give me 127 degrees of freedom, right? So if I wanted to be really conservative, and let's just, in the spirit of being conservative, let's just say that's what I do. So I'm going to say degree of freedom 127. Now I'm thinking about this, we could probably use degrees of freedom 221. I don't know that it's going to make a huge difference here, but let's see if we do degrees of freedom 127, and we hit calculate. It's going to give me a critical Q of 4.1 at alpha equal 0.05, right? We don't want to get too crazy. We'll leave 0.01 alone. But so this would be our critical value. 6 and 4.08. It doesn't make that much of a difference, right? So for this example, we'll just keep doing what we did here, and we'll just use 227, and we'll just be super conservative with our approach. Okay. So what we end up with, if we go through and we take a look, so we got a Q critical equal to 4.10. This is alpha equal 0.05. Okay. How do we use this to get back to a critical T value? Divided by the square root of 2. Which gives us T critical equal to 2.90. Okay. And so this is going to be our critical value, right? For our contrast, our exploratory contrast that we're working on here, right? We went through and we had no idea, right? Or we were too lazy and didn't think about it on the front end. But once we ran through and we took a look, then we imagined what we wanted to take a look at. But the problem is we went through and we already made all the comparisons in our head already, right? And so what we want to do is we made 12. Can't really get with this in terms of a good plan of doing this. So what we're going to do is we're just going to go conservative. And we're going to hijack Tukey. We're going to set R equal to 6. That's going to control for 15 comparisons. And I'm going to go through and I'm going to set my degrees of freedom at the most conservative, because that would be, in terms of Tukey, that would be the smallest degrees, the fewest number of degrees of freedom that would be tested, which is 127. And this gives me a critical Q of 4.10, which I can translate into a critical T. And now this is my, I'm not going to calculate p-values, right? I'm just going to go through and I'm going to run my tests. And any test that I get with a t-value of 2.9 or greater, I'm going to say is significant at p less than 0.05 based on my modified Tukey correction. If it doesn't hit this, then I would say, well, it was close. At per comparison error rates, it was significant, but it didn't turn out to be significant after my made correction for all the stuff that was going on here. Okay, and so this is pretty conservative. This t-test, I think it's a p. I mean, if you were to go through and take a look at T critical of 2.9, it's going to be associated with p equals 0.004. Right? We're making a pretty big correction here. Okay, but in different schools of thought. But if we're wanting to be very careful about sort of doing this, this might be a way we would go about that. Okay. So questions about how we went through, and if we were to go with 5, it would have been, our critical value would have been 2.77, which is still close, but not quite as stringent. That would be associated with a p-value of 0.006, right? So it's still extreme, but so wanting to go through and come up with a game plan. So my plan moving forward is I'm going to run 3 contrasts at per comparison error rates. And these contrasts are going to be looking at within each of my groups. I'm going to compare combat against all other. And then what I'm going to do is I'm going to go through and I'm going to do some exploratory stuff. I'm going to go through, based on eyeballing this, I'm going to compare my negative group versus all other against for each one of my vignettes. But here, because I'm assigning myself a penalty to this, I'm going to go through and set my critical value to 2.90. If I exceed that, it's significant to be less than 0.05. If it's not, then I say, well, it's close. I just didn't quite make it. Okay. Questions on this? Yes, Sam?
I didn't get the part where you said you have 12 comparisons already.
Mm-hmm. Do they do that for a p-value median? When I look at this, right, when SPSS plots this out for me, and I take a look, I had, going into this, I didn't know what this was going to look like. But this graph came up, right? And I was like, oh. Well, it turns out, and I had forgot about this, but what I really was, before I even ran this, I just wanted to compare my negative group to the other 2 groups at each one of my assessment points. Right? Well, I know that because I looked at it, and I just eyeballed what was the biggest differences in there. And so, functionally, from a theoretical standpoint, I've already ran through and ran all of these contrasts, right? I just, in my head, went through and ran all possible contrasts in each one of these time points, right? And what I did is then I went through, after I looked at it, And then I went through and cherry picked which ones I thought would be most likely to be significant. That's a problem. We can't do that, right? And what I'm doing is I'm saying, well, what I did is I ran all possible pairwise comparisons at, for vignette 1, for vignette 2, for vignette 3, and for vignette 4. That's going to be a total of 12 pairwise comparisons. And so I just want to, and I feel bad about that, right? I'm guilty. So what I'm going to do is I'm going to penalize myself for that and say, well, I can't just run them all and then pretend I only ran 3. I ran all 12. I'm just picking a modified 3 version out of this based on actually after I looked at it all. And so what we're going to do is go through and correct that. Kind of see what's going on there. And this is the issue with any post hoc test, right? Post hoc test is assuming that you've gone through, you just looked at it. And after you've looked at it, cat's out of the bag, right? The genie's out of the bottle, no getting that stuff back in there. It's already happened. I can't undo that, right? Because now what I'm going to do is I'm going to be tempted to just tease apart the ones that are the most different. And so essentially what I'm doing is penalizing myself for doing something. So the exploratory stuff is an all or nothing thing. Okay? So I'm penalizing myself for things that I didn't run out on paper, but I ran in my head. Does that make some sense? Okay. So what we want to do then is go through, and our first approach is we're going to go through and we're going to run our first contrast here, which is going to be combat versus all other for each one of our groups, right? So this is going to be our within so these are going to be our within subjects contrasts, okay? And so this is just going to be like the stuff that we had done previously. So we're going to go through, we're going to go analyze and go, or wait, first before we do that, we're going to go data, we're going to split file, we're going to organize output by groups, and we're going to set classes for a grouping variable here, okay? And we're going to go to analyze, general linear model, repeated measures. I'm going to have my 4 factors here defined. What I'm going to do now is I'm going to remove class from the equation. Okay? And so what I'm going to essentially do in this next step is I'm going to run 4 within subject, or excuse me, 4 one-way ANOVA models. And the reason I'm doing this is it just gives me everything I need in an easy step that I don't have to worry about going through and trying to figure out means and things along those lines. So this isn't, we're not running this to get statistics. Well, yeah, we are a little bit. But we're going to go through and run these because these 3 models are going to, these 3 one-way ANOVAs are going to give me all the statistics that all the figures that I need to go through and calculate my planned contrast here. So we're going to go through and we hit OK. And it's going to say, oh, I can't give you homogeneous stuff. But again, we're going to start with our negative class. Okay? If we go down through, we see our descriptive statistics for each, and this is just specifically for our negative group, right? So we've got the mean friendship rating for accident, combat, assault, disaster. You know, this is all stuff that we don't particularly necessarily care about, right? I mean, we're still seeing within subjects effect here. This isn't meaningful. This doesn't tell us anything, right? But what we want to do is we want to go up and we want to say, okay. So what I want to do is I want to compare my combat ratings with all other ratings here, okay? And so I'm going to run within subject contrast. So what are my weights that I want to use? Alex, what did you say? Perfect, right? So we're going to have for my 3 groups that I'm thinking are going to be bigger, right? I've got 3 3 assessments on the one side, 1 on the other, right? And so I'm going to say value of my first contrast is going to be 1/3 times 7.48 plus 7.39 plus 7.39 minus 6.73. You see what I did? -1 is kind of implied here, right? 1/3, I just kind of shortened this up. I could take 1/3 times this, 1/3 times this, 1/3 times this, but it's just kind of shorthand for what we did there. And if I go through and I calculate this, I get the value of my contrast, 0.690. Okay. People see how we set up that contrast? Okay. Easy peasy, not a problem. This is pretty straightforward stuff. Same stuff that we did with our one-way models. Okay. Now what we want to do is we want to calculate our test statistic, right? And so remember that this is going to be value of my contrast, 0.690, over, we go 1/3 squared plus 1/3 squared plus 1/3 squared plus -1 squared times my mean squared error for my within subjects of x. Okay. Then we go through and we take a look. What is that going to be, Morgan? 1.634. All over number of people in our sample. Yeah. And then we're getting that. Okay. So Stephanie, what is this denominator represent? Yes, standard error. The answer is always standard error, right? Now you know all the passwords of my stuff. Yeah, this is just your standard error right here, right? And so we've got the value of our contrast over a standard error. That's a statistical test, okay? This summation can get kind of a little bit tricky, right? But just know that all we're doing here is we're taking the square, we're summing our squared weights, multiplying it by our mean squared error over our sample size, taking the square root of that, that's my this standard error for this within subjects contrast. Okay? And if I work this out, it's going to give me 3.10. Okay? And if I go through and I take a look, pad calculator, I say this is 3.10 with degrees of freedom. How many degrees of freedom? Not quite 44. Where do we get our degrees of freedom from? 73, right? This is going to be the degrees of freedom from our associated with our error. We're going to take and with our greenhouse Geyser correction, our degrees of freedom are going to be a decimal place. We'll just go through and say 73, and we compute our p-value, it gives me the p-value 0.003. Okay. So this is good, right? So this tells me that we have evidence that for our negative class, participants in the negative class are rating willingness, combat survivors is less willingness to provide friendship relative to the combination of motor vehicle accident, sexual assault, and disaster-related trauma. So this is pretty cool, right? So this turned out. Another thing that we can do easily from the stuff that we've already calculated, we can go through, calculate 95% confidence interval for our mean difference, okay? Here, this is just going to be 0.690, which is the value of our contrast, plus or minus our standard error, if we calculate this out, right? It's going to be 0.223 multiplied by 1.993, okay? So I got this is my standard error that I already might as well do it because I've already calculated my standard error. That's easy, right? Where did I get this? It's just going to be my critical T for 73 degrees of freedom. And so again, if we go through, it's a big day, folks. We got 3 different stack calculators up and around here. Critical T calculator, so this silver one, go through, we got degrees of freedom, 73 at alpha 0.05, 1.993. So what's nice is that we can just go through and run this stuff easily based on the output that we get from this. Now we could run all of this. Really the only thing that we need is our degrees of freedom error and our corrected statistics from this one-way ANOVA from this group, but we've got all of that set up and ready to go. And so if we calculate our confidence interval here, we got 0.25, 1.13, right? And so we're saying that based on these data, we would expect the average difference between ratings of friendship for combat survivors versus all the other types of civilian trauma among individuals identified in this negative class is ranging anywhere from 1/4 of a point to a little over 1 point on our 0 to 8 scale. And this is nice because it gives us a range of the sort of magnitude of the difference that we should expect in terms of friendship ratings. And again, everything in this design is pulling for people not to be jerks and just write 8 across the board, right? But we're still seeing effects in this group, which is kind of impressive. Okay. Last thing we might want to do is calculate an effect size. Okay. What are we thinking about in terms of effect size for this problem? What are our options? Can we do standard deviation of the difference? No, because there's not really, it's 3 groups, right? I mean, that's not something we could, I mean, we could maybe get at it and calculate, but that would be a weird and cumbersome thing to do, right? What are our other options? What's that? So you use it. With pooled variance, right? And do we have to worry about pooling with our within subjects effects? No, because we got the same number. It's the same people, right? And so we can just take the average of the variance and take the square root of that, right? And so if we do that, we could say average variance is going to be 0.993 plus 1.313 plus 1.080 over 4. 608, and then I'm just going to take average variance Okay. So basically what I just did is I took my standard deviation, squared those to make sure I'm working with variances. Calculated my average variance, got an average variance value here. And these are all, yours might be a little bit off if you're just punching these values in, because mine was just all saved in my calculator, and so it's not rounding error. Yeah, what's going on, Sophie?
I was a little confused because I thought this was between, so you're doing negative versus outlier.
Oh, no. These are within subjects. Okay, so this is for the negative class, right? We're comparing combat, ratings for combat versus ratings for all our other vignettes. Okay. So when things get a little bit different when we start doing our between stuff. Okay. Yeah.
So these variances are coming from within, like the combat and the other groups?
Yep. So if you look at, so when we ran this is, so when we run our analyses and split by group, 1.047 is just 1.023 squared, 1.73 squared, 1.146 squared, 1.039 squared, right? So I'm just taking this from my descriptive statistics.
And this is within the negative.
Within the negative class, yeah. And so, looks like, based on those values, I get a average standard deviation, because again, average variance, then work to the standard deviation, then I can calculate D. It's going to be 0.690 over 1.268. It's going to give me 0.544. And this is nice, right? Because what I can say now is this is, based on this effect size, looks like that individuals in the negative, who I've identified in this negative class, are scoring, are rating willingness, their willingness, ratings for willingness to provide friendship to a combat survivor about a half standard deviation lower than ratings for willingness to provide support for other civilian types of trauma. So we've got a lot of different things that we can go through, and there's a lot of different approaches to understanding some of this stuff, right? So we've got our test, which tells us we've got a statistical, that the comparison between our combat versus all other for our negative group is statistically significant. We're seeing that the magnitude of that difference in the population is our best guess, ranging from somewhere to 0.25 to about a full point reduction relative to those. And then we're seeing that in a standardized effect, we're getting about a half standard deviation or ratings for willingness to provide friendship to trauma or combat survivors, about a half standard deviation below rated willingness to provide support to other groups, right? And so what this is doing is it's going through and giving us a number of different ways to go through and take a look at this, okay? So what's the next step? What do we do now? Yeah. We won't worry. That starts to get complicated. We could probably figure out how to do it, but we won't do it there. Are we done with the negative group? Yeah. So who do we go on to next? Right. And so then we go through for each one of these. Do people want to go through another one of these examples, or you kind of got an idea for how this is working out? Okay. This is going to be the exact same for each one of these, right? You're going to go through the exact same process, and if we do. If we do that, we're going to see that this is how things play out. I guess you could say this is. So when we run this contrast across each one of our within subjects contrasts, we see that for each one of these contrasts, they all turn out as statistically significant, right? Even though the value of our contrast, the difference is, I mean, down here we're talking about 0.2 of a point, right? But again, these are repeat measures designed with like 84 people. This just has tremendous power in this, right? And so we're seeing that, again, even with this small of an effect, we're still getting something that's clearly statistically significant associated with a small effect, a medium effect here. Okay. And so it looks like that, yes, across our individual classes, we're seeing that people are consistently rating, indicating less willingness to provide support or friendship to a hypothetical survivor of combat trauma relative to other trauma types. But it looks like this effect is much more pronounced in our negative group as opposed to our others, right? And this is where some of your effect size stuff starts to become important, because if I just go through and take a look at my p-values, right? This is a much smaller p-value, but my effect size is a fraction of what this one is, right? Why is this p-value smaller for here, even though the actual difference is less than half of what that is? What's that? Yeah, I had more people in the group, that's part of it. What else is going on? Had a lot less variability in this group, right? Had most variability in this group here. So even though we're seeing sort of a much greater difference here, so that part of that is going in, variability is going to get caught up in your effect size too, right? That's part of your standardizer. But being able to go through and say, yeah, they're all, so instead of just saying, yeah, they're all statistically significant, we can go through, we can say, well, true, but it looks like the magnitude of effect is considerably larger for this group of individuals than this. And this starts to help bring apart, remember, our interaction is saying that group membership is impacting the pattern of means across vignette ratings. This starts to help us tease that apart in a way that makes some sense. There are different ways to look at it. Again, we could run 30 pairwise comparisons. Let's not. Let's just do something that's more efficient and sort of more consistent with what we're seeing there. Okay. So this is our within. What we want to do now is we want to go through and think about what are we going to do for our between subject stuff. Now remember that what we were going to do is we were going to again run contrasts. Can I erase this? For our between, again, remember we're going to go Meg versus all other. Okay. At each one of our assessment points. But our critical T for these comparisons, because we corrected for them, is going to be 2.9, is that right? Yeah, boy. Incredible memory, that's what I'm known for, remembering things all the time. Okay. So what we can do now, and this is actually, with this, we're going to let SPSS do the work for us, right? Which is going to make our lives quite a bit easier. So what we've gone through, a couple different ways we can do this. We've got contrasts to run across each one of our assessment points, right? So going back up here, so we're gonna run a contrast here, 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 and here, right? But what we might wanna do before we start is run just, as we go through, we can run our,
Did we keep our file split today?
what's that?
Did we keep our file split today?
Nope, is our file split on this? It is. Thank you for reminding me. Just sort, that'll fix it. All right. So what we're gonna do now is we're gonna go through and run analyze. Compare means, now we're just gonna go down and drop a one-way ANOVA. Okay. So what we're gonna do is we're gonna say we wanna run a one-way ANOVA for MVA, combat, assault, and disaster. Want to compare those by class. And now we can come into our contrasts and we can say, all right, what's the value of my contrast going to be? I've got negative is coded 1, benevolent is coded 2, interpersonal is coded 3. What are the values of my contrast going to be? What are they, Morgan?
-1, 1/2, and 1/2.
Perfect. And we got -1 for my negative group, because I'm going to expect that to be lower. 0.5. 0.5. Oh, you stupid thing. 5. Okay. I'm going to hit continue. I'm going to go to options. I'm going to want my descriptives, just because I'm interested. My homogeneity variance tests. I'm going to ask for Welch's because I already know that I violated homogeneity variance. I already know that. We already requested those. I know that's going to happen. And so I'm going to go through and request those. And then I'm just going to go through and I'm going to hit OK. And then this is pretty slick business. Okay? What this has done is it's just run one-way ANOVAs for me across each one of my vignette ratings, right? If I go down through, I take a look here, is my homogeneity variance test. And we see that I violated homogeneity variance each time, right? And so this is going to be important because what I've done now is I know, thinking back to stuff that we did last year, right? I've have unequal sample sizes. I've violated homogeneity of variance. My distributions are garbage, right? And so this starts to become important in thinking about if we want to create standardizers for effect sizes, we probably can't and shouldn't just be going hijacking coefficients out of our ANOVA tables, right? We probably need to go through, take a different approach with stuff. So aware of that. But if we go down through and we take a look at our effects, we see that based on this. And I would encourage you to do this first. So before you go through and sort of start rooting around with the contrast and pairwise tests and things like that, when you're running your between subjects comparisons with 3 or more groups, just run an initial ANOVA off the bat. That can be nice because if I run so for example, I take a look and I see that I don't have a significant effect, or that my one-way ANOVA for friendship ratings for motor vehicle accident isn't statistically significant. What does this tell me, Katie? For friendship ratings. That what? Well, it's not significant, so we don't have evidence for it, right? So what we're saying is if I go through and I take a look at this, right, and I see that my omnibus test isn't statistically significant, do I need to start fooling around with stuff? No, right? Using this as kind of a rule out, right? I see that for ratings of willingness to provide friendship for motor vehicle accident survivors, this test suggests that I don't have any evidence of reliable differences across these groups. Cool. check that off my list, right? Combat, it does look, I got a significant omnibus test. Now, I also violated homogeneity of variance, right? So I'm gonna go down through and take a look at my Welch's, but it's still turning up as statistically significant for my Welch's, right? And so, okay, I'm gonna go, maybe go through and proceed with this. For my one-way ANOVA for ratings of willingness to provide friendship to assault survivors, that's not statistically significant. Go down through, take a look at my Welch's, that's also clearly not statistically reliable, right? So my omnibus test is telling me that I don't have sufficient evidence to conclude reliable differences in the mean value of friendship ratings for assault survivors across groups. So I'm not going to worry about that. Same thing for my ratings of friendship for survivors of disaster vignette. Check that off my list. So really, how many things do I have to worry about here? Just the one, right? This is going to be an important thing to consider. Now, some people will say, well, you just run an extra test, you don't need to do that. But, boy, if I was going to go through and actually look at all 12 pairwise comparisons, right, if I wanted to do a true, if my approach to this, let's say I was just maybe a skosh in and said, you know what, I'm just going to go through and I'm going to compare, literally compare all possible pairwise comparisons at each one of these. I've got 12. You know what, I'm corrected for 12? I'm going to go through and I'm going to look at all 12, right? That's a lot of tests to just run through and take a look at. And even if my omnibus test is not statistically significant, it's possible that one of those pairwise could cross and be statistically significant. And then I've got stuff going on. And so my approach that I like to take, and I have different thoughts on this, but I like using this omnibus test because it can kind of help me rule stuff out. Like, okay, nothing to see here, moving on to the next thing. Nothing going on here, but okay, this looks like there's something going on here. Maybe go down through and take a look. Okay. So again, we've got violations of homogeneity of variance. So really, we're looking at our Welch's test for all of these. The only one that comes up as statistically reliable is my combat one, which makes sense to me given that I've looked at the means, right? Going down through, and I look at my contrast coefficients. I've got my negative group set is -1, benevolent is 0.5, interpersonal is 0.5. That's what I want. Cool. And so now what I can do, and this is a nice thing letting SPSS do the work on these between subjects contrasts, is it's going to provide a correction for homogeneity variance and stuff like that. We do it by hand, but it'd be a pain in the ass, take us a long time. And so what we can do is we can go down through, we can take a look, and so we're going to look at friendship for combat. We're not assuming equal variances. And so we see that we have, SPSS is giving us a statistically significant contrast for this effect. Okay, but you'll also notice that if we were just not being conscientious about the extent to which we're violating assumptions and things like that, I could easily decide that I have a significant discrepancy or a significant difference for ratings of assault plot. It looks like there's probably nothing there, right? But also remember that differences in these ratings are really, really minimal. Also, we violated almost all of our assumptions, right? There's nothing that we checked off that box and said, cool, we're good to go outside of having large cells, right? And so I'm not comfortable if we were to go through and gather a lot more people. I think we would probably continue to see this, but given all of the violations of assumptions, I would not want to go through and start making strong interpretations about these, right? But the combat stuff is pretty clear. What's the only thing that we should need to take into account? Yeah, we corrected for a whole gang of tests that we just did in our brain, right? Based on our correction, do we claim a statistical a significant effect there? No, we can't, right? Now, what we might want to do, and probably should do here, is even though it's not statistically significant, after a pretty massive correction, probably not going to just throw up our hands back, well, tried our best, right? Probably want to elaborate on this a little bit, right? But again, letting SPSS do the work, we can go through, and for this, we can calculate a 95% confidence interval around our effect here, or around our mean difference, right? And so we can say our mean difference is 0.75, right? And I just pull that right off of my table. I don't have to think about that. Plus or minus my standard error. Got a standard error right there. That's nice that it gave me that. I go through 0.144. And then, or wait, excuse me.
2.7.
2.7, no. 0.271 multiplied by my critical value. In this case, I'm going to look at a critical T with 49 degrees of freedom. It's going to be 2.010. We're going to go through and pull that off of our nifty calculator. Right, again, I'm just pulling that off of my corrected degrees of freedom. Is going to give me confidence interval around the mean difference, 0.21 to 1.29. And this is nice because SPSS just gave me the stuff that I needed to go through and calculate that, and so that's pretty easy to do, right? And then the other thing I could do is I could also go through and want to calculate an effect size, right? Now, what should we probably be thinking about in terms of our calculating an effect size here? What should we probably use as our standardizer?
Why did we use 0.75?
What's that?
Why did we use 0.75?
This is 0.7. This is the value of our contrast. This is because we have used a standard set, right? So this is literally the number of points difference between for ratings mean level of willingness to provide friendship in our negative group versus the combination of our other two. Okay. So again, if you look at here in your contrast, the value of your contrast, we see a 0.21 difference for this one, 0.75, 0.32, 0.29. That's where that's going. Is that?
Yeah. Can you repeat the function of this 95? What is this 95% confidence interval around? Is the value of the contrast?
Yeah.
And
Just
for what purpose?
For what purpose?
Yeah.
To sort of say, just because interval estimates are better than p-values, right? I mean, the idea is just to say, well, we are seeing a difference, and that difference is about 3/4 of a point difference in terms of willingness to provide friendship for the in the negative group versus the combination of benevolent and interpersonal. What's our best guess? So that's our point estimate. What's our best guess? If we were to replicate reasonable values for the value of this contrast, ranging anyway from 0.21 to about a point, right? So again, just trying to sort of provide some context for that effect, right? Because we said it wasn't statistically significant after we corrected. We corrected for a whole lot of stuff. And if we look at that plot, it looks like there's something very clear going on, right? So I want to, in my interpretation, we want to say a little bit more about this than just saying there's nothing there. Yeah?
So when we do like contrast, do the correction and stuff like that, do we apply like the same like flexibility we do with like if we found like a say like p=0.051 for some test, we
I
kind of
would.
say that.
I mean, and again, right, remember that, so we've taken a pretty stringent approach here. I mean, I used, so I'm correcting for more tests than, so I actually ran a lot of other stuff too, right, that we didn't correct for. I used the lowest level of degrees of freedom. I don't know what degrees of freedom are going to make a whole lot of difference in here, right? So I'm just saying, hey, I'm just kind of on a fishing expedition. I just kind of went out here and looked, and so I'm going to apply pretty stringent correction. But you could also make the argument that from a philosophical standpoint, there's no such thing as a type 1 error because everything's different to some level, right? And type 1 errors don't exist, right? I don't know that that's going to fly in your experimental world. You guys get pretty worked up about type 1 errors. But you could make sort of the argument, again, going back to some of that Cohen stuff, that our big problem is our type 2 errors, right? We rarely have enough people to go through and have sufficient power to test much of anything. And so you could get someone to say,
completely the opposite and say, ooh, you went way too overboard with this, right? And there's no right or wrong answer. This is just strength of justification for what you're doing. Now, with this, I wouldn't be comfortable probably just be like, oh yeah, no, type 1 errors don't exist, I'm just gonna do whatever the hell I feel like. That's probably not gonna fly. This, probably a little too severe, right? If you actually look at the p-value for this, it was functionally the same thing as bond for undercorrecting for 12, or for all of your stuff. And so I just sort of wanted to give you guys kind of a scenario for what you might do moving forward on your problem sets. I'm gonna give you more guidance so that you have something sort of to shoot for, and so that I don't have to figure out what you pulled out of the hat to do for corrections. But yeah, there's a lot of flexibility in this, right? And so it's up to you to justify what we did, why we did it, and so that's kind of that. Okay. Cool. So last thing though we want to do here, it didn't register as statistically significant after our pretty massive correction, but maybe we want to go through and calculate an effect size on this, right? Here we've got a between subjects factor, we've got different people in different groups, we know we've got violations of homogeneity of variance, and so what I'm going to do is probably say, well, I want to go through and calculate a versions of Hedges G here, right? Now the tricky thing is we've got 3 different means, right? Or 3 different groups. But we can still use our pooled formula for however many groups we want, right? What we're going to do is we're just going to take 44 minus 1 times 2.993. Again, if this is just a variance, I'm just pulling this out of your descriptive statistics. I'm taking your standard deviation and squaring that. Okay. Plus 94 minus 1 times 1.11 plus 85 minus 1 times 0.776 all over 44 plus 94 plus 85 minus 3 gives me a pooled variance of 1.351. Excuse me, a pooled standard deviation of 1.162. Okay. So again, with this, I'm just taking the pooled variance of all the groups that are included in my contrast. Going through and just using that pooled variance, so weighting this out a little bit, right? And so this is important because this clearly has the largest variance, right? But it's got the smallest number of people in it, so it's getting weighted appropriately, so it's not sort of just running over stuff, right? And then calculate our effect size is going to be 0.75 over 1.6, 1.162, 0.645. So this is important, right? Because we didn't hit our mark for statistical significance, right? And so with this correction, we would say, well, we can't claim statistical significance if we're sort of sticking hard and fast to this, but we also applied a really stringent correction, right? And we're seeing that on average, individuals in our negative group are rating willingness to provide friendship about 0.65 standard deviations below the mean of friendship ratings for our 2 other groups. It would be hard for me to say and take seriously that there's nothing going on in here, right? And so this is where you want to go through. And in this example, right, I said, all right, this is what we're going to do, and we're going to stick with this, and then we're just going to move forward, which is a high principled thing, which is probably what you should be doing, right? Things start to get murky if after we've gone through and done this, like, I changed my mind, we set R equal to 5. We set R equal to 5 instead of 6, we control for 10 comparisons instead of 15. This becomes significant, right? But again, at the end of the day, hopefully what you got out of this sequence is that all that's kind of arbitrary. I mean, this is just sort of markers that we can move around a lot, right? You just want to know sort of what you're doing, why you're doing it, and then just be able to sit in front of colleagues and say, yep, this is what I did, and hopefully tell the truth and not conceal that you actually started out with a more stringent comparison. But again, if you understand what's going on, whether we correct for 15 or 10 doesn't change my interpretation of what's going on here, right? I mean, it changes whether or not in my paper I can claim statistical significance at some sort of level, but at the end of the day, it shouldn't affect at all my inferences about what's going on in these data, right? I mean, we've got a system that we kind of have to play by, but sort of wanting to think flexibly about that as this is you're moving forward with stuff. Okay. Questions about any of this? Okay. So at the end of the day, and so this is fine, right? We all go through and we calculate our analysis and do X, Y, and Z. But remember that the whole reason we did this is that we want to go through and figure out what's going on in this. Remember at the whole start of this, we had a within by between interaction, right? We found that belief class impacted the pattern of means across our repeated assessments, right? And so what's going on with that? Well, there's an infinite number of ways we could have approached this. We chose one out of all possible universes, right? But I think it sort of gives us a sense that says, in general, it appears that regardless of class, or excuse me, across all classes, that individuals reported less willingness to provide friendship to combat survivors relative to other forms of trauma, although it seems that this effect was much more pronounced in individuals in the negative class relative to others, right? We also found that evidence of this in a marginally significant effect after a fairly severe correction, that in a between groups analyses, that average friendship ratings for the combat vignette were 6.65 standard deviations lower for a combat or for a negative group relative to our other two groups. We found small effects, sort of mean suggest possible differences for MBA, assault, and disaster, although none of those turned up statistically significant. I would also note that we're asking people trick questions, right? It's a hypothetical, like how willing are you to be a nice person to people who have experienced something horrible? Probably everybody's going to straight towards the high end, but we're still seeing effects in here. But again, thinking about like if we would have done this in a completely between subject design, none of this would ever come out, right? The only reason we're teasing apart some of these very subtle effects is because we went through, included this repeated measures component to this, where we're looking at sort of among individuals, counterbalancing these, but we're getting ratings for all these, so people are acting as their own controls. We're taking that individual difference variance, we're sucking that out, and so that all we're left with is just sort of within person change across here, and then modeling in just basic belief class with stuff. Yes?
I feel like this answer is right in front of you. Why is it 0.65 standard deviations below?
Well, because, and no, this is the thing, some people get worked up about signs on contrast, right? But the way we set this up is we set these other two groups to be positive and that negative. So these are, we could say that you could easily interpret this as the combination of the interpersonal and benevolent groups are provided friendship ratings about 0.65 standard deviations above the negative group. And that would be perfectly fine. And just for me, suggesting that, hey, we've got a group of people who are scoring substantially lower than other people kind of captures sort of the feel of it. But that's a conceptual issue, and you could easily interpret the other way. Yeah.
So when we are talking about a combination what the weights does is that it kind of helps like disperse the, because before I was confused that if you add these two things, it would be greater than this other thing because you're adding it, but with the weights it seems like you're kind of cutting it so that there's like equal, you know,
Yeah.
you know what I'm saying?
No, yeah, and so if my weights are negative 0.5, or excuse me, 0.5 and 0.5 and negative 1, all I'm doing is I'm just taking the average of these and comparing it against that, right? Or if I have 3 groups, I make this 1/3, 1/3, 1/3, minus 1. I'm just taking the average of these minus that. The only reason we need to specify the weights as numerical values instead of just saying, all right, I'm just going to take the average of this group and put it together in the average of this, is that at least in our, if you have unequal sample sizes, then there's other stuff that goes on, right? But what we need in our hand calculations, we need that value of the weight, because that actual number goes in the calculation of our standard error, right? So if you think about with our within subject contrast, we actually need to have a value for that weight in order to calculate our contrast. Otherwise, I could just say, yeah, take the average of these 2 groups, compare it against that one, and then I'm fine, right? In your actual value of your contrast, that's all that's going on, right? And if I had if I had 4 groups, right, and I said negative 0.5, negative 0.5, well, now I've just compared the average of these 2 groups versus the average of those 2 groups. I mean, nothing fancy going on here. The only reason we need to go through and make sure we're specifying this, one, for coding, it tells SPSS what it wants us to do. And then for us, remember, we're going to take the sum of your squared weights as part of your standard error. And so we need to take 0.5, square that, 0.5, square that, square that, square that, add those up, right? So, I mean, I could easily go through and set this up so that it's 1, 1, negative 1, negative 1, right? But that's not a standard set, right? But these weights don't add up to, the absolute values of these weights don't sum up to 2, they sum up to 4, right? And so you're going to get, you could set these weights, and your physical test is still going to be the same, because you're taking the sum of your first 2 groups minus the sum of your second 2 groups, which is a perfectly fine way to do it. It's just the value of your contrast is going to represent the difference between those groups and the actual scale that you assess them in. And so then if we go, then we can't take the value of your contrast and calculate the effect size. We got to go through it, do that manually, which is kind of a pain. But the only way, remember, one way you might want to do this is if we have a situation we're trying to run this in SPSS. I'm not going to worry about this for you guys, but if you were concerned, and I had my weights were negative 1/3, negative 1/3, negative 1/3, and 1. Does SPSS let you put negative 1/3 in? No. 0.33, negative 0.33, and negative 0.33 plus 1. It doesn't sum to 0, right? You've still got a small amount, and SPSS will give you a warning that says, hey, you're not good with this, right? So what I could do, if I wanted to make SPSS happy, I could set that to -1, -1, -1, and that to 3. Statistical test is going to be the same. P-value is still going to be the exact same. The value of your contrast is going to be different. It's going to be larger. Your standard error is going to be larger too, because standard error is a function of your the square of your sum of your squared weights. It's just the value of my contrast here and the value of my contrast here. This is going to be in actual units, and so I can just look at that and plug that in the numerator of my effect size, and I can run this and interpret the confidence interval around that is sort of that upper and lower limits of the expected difference between the 2 groups. Here I can't do that. That's fine for the statistical test, but I'm going to have to go back through and recalculate a bunch of other stuff because I've chosen different weights. And so, in general, if you're doing things by hand, no reason not to do this. in SPSS, probably gonna be fine. It's not everything's gonna sum to zero, but you're gonna be close enough, right? But if you really want to get precise, or if you are working with values that are really, really small, maybe you might want to do this, but that's kind of what's going on there. Does that help? All right, any other questions about this, the set? So we wanted to go through this one. This one's a little more complicated with the ordered means. Again, that screencast and online if you wanted to watch that. I mean, basically all we're doing with that, remember we have 3 treatment groups across repeated assessments, right? And in there, what we did, the approach I'm taking, I'm saying, okay, well, what we want to do, it doesn't make sense to run statistical tests to see if people are different. Like, it's very clear that there are, because there's 1 billion people in that sample and massive drops, right? So, but what we do is then go through and run some t-tests, not because we're running t-tests, but because that gives us values that make it easy to go through and calculate effect sizes for each group, calculate confidence intervals around expected difference for pre-post, and then confidence intervals around the paired sample, or the repeat measures effect there if we wanted to do that. And then running one-way ANOVAs and pairwise comparisons at pre-test and post-test, right? So then we go through and we just say one-way ANOVA at baseline, and we look at pairwise comparisons. Same thing at post. Here, the thing to think about is that if you just run post hoc tests at pre and post, it's a one-way ANOVA, so all of those comparisons meaningful. Yeah. Well, what it's going to do is it's going to correct for 3 here and 3 here. So you're only correcting for 3 each time point instead of 6, right? And in this case, we've actually got 6. And so you can set here, if R is equal to 4, how many comparisons are we adjusting for? 6, right? And so what we can do is the same thing we did here. Just set, catch 2 key critical for R equals 4 with sort of, and I think I went conservative there and said sort of the degrees of freedom for the smallest comparison. And then what we need to just do is run pairwise comparisons across each one of those, and then just sort of call it good with that. Feeling okay? Was this helpful? Okay. These designs are really tricky. There's just a lot of stuff, and there's no one way to go through and do it. Again, sort of the spirit of this entire semester is like, hey, here's 15 different ways to do it. Choose the right one, and I'll be judging you. But it's important to think about, like, as you're approaching this stuff, you know, what are my options? What are the considerations? What's my best way moving forward? And then going through and doing this. I mean, these, again, are going to be the bread and butter for a lot of dissertations, for experimental stuff, particularly Sam, you're going to be doing, and Alex, you're going to do some of these types of things, right? And so wanting to just be familiar with this and not get freaked out. When you do get a 3-way interaction, then you have to figure out what the hell to do with it. And this should hopefully give you some ideas. Any other questions? All right, cool. Thank you so much.